This video will demonstrate how typical existing parabolic troughs, like this model, operate. The scale is 1 inch equals 1 foot. So the aperture is about 19 feet across, although some troughs are up to 23 feet across. There are currently tens of thousands of these operating worldwide, generating electricity. The aperture determines how much sunlight is reflected onto the collector tube. Wind loads limit that aperture size of existing troughs to about 23 feet. All parabolic troughs reflect sunlight onto the focal line. There are dozens of variations worldwide of mirror structure and size, but they all have the same relationship of the parabola to the collector tube. The rotation of the trough occurs under the parabola. This places the collector tube about 6 feet away from the rotation point, causing the collector tube to travel in a slow arc as the trough follows the sun throughout the day. A typical solar field will have thousands of these troughs connected in lines hundreds of feet long. At the end of each line of troughs, there's a manifold. The problem occurs where the collector tube meets the manifold. The collector tube travels in an arc, and the manifold is stationary. This requires a flexible joint to get the thermal fluid into the manifold. This flexible joint limits the thermal fluid to a synthetic oil. The oil is a fluid which makes it incompressible and will not expand as it heats up. A gas, such as superheated steam, cannot be effectively used due to the flexible joints. The 750 degrees synthetic oil is then piped via manifolds to a heat exchanger which uses the hot oil to generate superheated steam. This transfer of energy causes a 15% loss of efficiency. Superheated steam for generating electricity has temperatures and pressures which are not compatible with flexible connections. In addition, the properties of the synthetic oil limit the upper temperature range to 750 degrees Fahrenheit. Beyond that temperature, oil decomposition accelerates, adding life cycle costs. Finally, because the oil is below standard operating temperatures for generating steam, natural gas is used to boost the superheated steam to temperatures and pressures suitable for electrical generation. In summary, current trough apertures are limited to 23 feet, or about 6.77 meters. They have flexible connections, which limit the thermal fluid to synthetic oil. Transferring the heat from the oil to generate steam results in a 15% loss of energy and efficiency. The synthetic oil has an upper temperature limit beyond which decomposition accelerates. Those temperature limits require a natural gas boost to get the steam to the optimum temperatures and pressures required by steam turbines. Thank you. For more information, visit gensolar.com.